In this lesson, we're going to continue our journey of learning how to factor polynomials. In particular, we're going to look at factoring trinomials of a general format where the leading coefficient is not necessarily 1. So this is a broader case that can be applied to many different trinomials out there. Let's first just try going for it and factoring 10x squared minus 3x minus 1. The leading coefficient is not 1. Careful. So you don't want to fall into the practice of treating this as a leading coefficient of 1 and just doing what we learned in the previous lesson on simply factoring straight into the brackets. However, some people are able to just see it. So let's see how this would work. We want the first terms to multiply to 10x squared. We know that they should be beginning with an x term. So we basically have two options of multiplying to 10. Either 1 times 10 or 2 times 5. In this case, we have a limited number of options. You can imagine that this number could be different and could leave you with many possibilities. So to make sure the middle term works, we know that the inner and the outer multiplications need to add up to the middle term because that's where they come from. So what that means is 10x here, 10x times something plus 1x times something needs to give us negative 3x. And here, 5x times something plus 2x times something needs to give us a negative 3x. That's how the middle term is formed from the distribution step. We also know that the last terms need to multiply to negative 1. In this case, the only ways of multiplying to negative 1 are just by multiplying 1 by negative 1, and that's about it. So we know that we can only use a combination of 1 and negative 1 to make these work. So think about, can we do 10 minus 1 or 1 minus 10 to give us negative 3? No. So this one doesn't work. Can we go 5 minus 2 or 2 minus 5 to get negative 3? Yes, we can. 2 minus 5, so positive 2, so multiply that by 1, and minus 1 times 5. Let's check that. This is minus 5x and plus 2x would give us negative 3x. Great. So the middle term would check. The outer final constant term would also check. So in this case, this helped us out, the fact that the last term only had one option. You can imagine that if you have many options for the first term and many options for multiplying to the last term, you'd have a lot of options and it might get very tedious. Let's just finish this one up, but in the next slide we're going to work towards a more clean method of doing this. So here, the 5x needs to be in a multiplication statement with a negative 1, and the 2x needs to be multiplied by a positive 1. Let's just double check this. 2x times 5x is 10x squared, 2x times 1 is positive 2x, negative 1 times 5x is negative 5x, and negative 1 times positive 1 is negative 1. Does this give us the original back again, the expanded form? 10x squared plus 2 minus 5 is minus 3x minus 1. Great. So this here was factored form, and this was our expanded form. The answer to the question in this case would be this here. We want to work towards a method because the first and the last numbers could be more complicated than in the previous example. So if you see it right away, go for it, but let's have a backup method to work with. So let's begin by checking out this binomial times this other binomial, 2x plus 3 times 4x plus 5. You'll notice that I've just labeled them 2, 3, 4, and 5 so that we can track them as we expand. So this is the factored form, and we want to get it back. We want to see what the expanded form is so that we can watch it come back to factored form and see if we see a pattern. Alright, so the first term would be 2x times 4x, so let's write that as 2 times 4x squared. The next multiplication would be the 2x times the positive 5, so that would be plus 2 times 5 times x. The next one would be plus 3 times 4 times x, and the last one would be plus 3 times 5. You can see that that simplifies to 8x squared. The middle term is formed by going 2 times 5, 10, plus 3 times 4, 12. 10 plus 12 is 22x, and the last term is 15. So the question would have been, factor this. Factor 8x squared plus 22x plus 15. So how would we backtrack? How would we get it back to even this stage? Well, you'll notice the only real difference between this stage and the previous one is that the middle term was split. Now remember, when you have 4 terms, you can always use the grouping technique to get back to there. The grouping technique was covered a few lessons ago. So, all we really need to do is figure out how to split this middle term up so that we get the right combination, 10 and 12, so that when we group it, we get back to the factored form. So let's just notice that the middle term is formed by 2 times 5 and 3 times 4. Where did those numbers come from? 15 was 3 times 5, and 8 was 2 times 4. Can we make a generalization? Well, let's just look at the outer product. So let's take a look at outer product. That means multiply the first coefficient by the last term. The outer product would be 8 times 15. And I'm just going to write that as 2 times 4 times 3 times 5 because that's how that is formed. The middle term is 2 times 5 plus 3 times 4, which is taken from components of the outer product. So somehow we need to notice that when we go 8 times 15, 8 times 15 is 120. We want to somehow get 10 plus 12. Notice that 10 times 12 gives us 120, and 10 plus 12 gives us 22. Hey! Well, if this is going to work in general, what that means is we can look at the outer product and the middle term and find two numbers that have a sum of the middle term, so they add to the middle term, and they have a product of the outer product. Okay, so if you were just taking a look at 8x squared plus 22x plus 15, you would say, what's my product of the two numbers that are going to help me split this into a grouping question? The product is 8 times 15. And 8 times 15 is 120. The sum of my two numbers needs to be 22 because I'm splitting the 22 up. So basically we're looking for two numbers that multiply to 120 and add up to 22. We can do this similarly to as before. You could write out all the possible ways of multiplying to 120, 1 times 120, 2 times 60, and so on, until you reach 10 times 12. In this case, we know that that's where that's going. So we know that 10 and 12, both positive, to give a positive product and a positive sum, will be splitting the middle term. So we could write this as 8x squared plus 10x plus 12x. Order doesn't really matter here. You'll notice that if you put them as 12x and 10x, it would work out exactly the same. Now, let's apply the grouping technique. So factor the first two. What's the greatest common factor of 8x squared and 10x? Well, 2x. That leaves us with 4x plus 5. And what's the greatest common factor of 12x and 15? 3. Factor out of 3, you're left with 4x plus 5. Hey, check it out. We got the common factor of 4x plus 5 that we can factor out. And what's left in our bracket is our 2x plus 3. So we've got a method for the factored form. And it involves looking at the total product from the n numbers, because those are the ones that get to be how they are by multiplication of the distribution step, and the middle term, which is made up of two numbers that multiply to the outer product and sum up to the middle term. So what we just described is called decomposition. You're decomposing the middle term into two items so that we can use grouping. It is the ultimate trinomial factoring method because it will work on any trinomial ever. So it is your backup method. It is something very important to learn because sometimes we just don't see a special factoring format, or maybe we can't really find a way to guess the answer. So this method will give you the option of finding it. So let's recap what this is, what the process is. The process is to split the middle term so that these two numbers that you split it into have a product of a times c, the outer product, and a sum of b, obviously because these need to be equal to this step. Afterwards, use the grouping technique, factoring two at a time, and you will get back to the factored form. Let's see it in action. Here's a trinomial with leading coefficient other than 1. So we're going to use decomposition. So the product is found, as we noticed in the past, is found by taking the first times the last. The 12 times the negative 3, which is negative 36. The sum is the middle number because these two numbers will need to add up to 5x so that it still works. So 12x squared is still there, minus 3 is still there. All we're doing is separating the 5x into two terms with the following properties so that the sum is 5. Now we can look through all the possibilities of multiplying to get 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 times doesn't work, 6 times 6, and that's it. Those are all the possibilities that you could have here with different signs, of course. And because the product is negative, that means one of our numbers will be negative, resulting in looking for a difference of 5. So let's look for two numbers that differ by 5, and that's 4 and 9. 9 minus 4 will give us 5, and 9 times negative 4 will give us negative 36. So we can use these two numbers as coefficients of splitting the 5x up. Remember, you can use it in any order if you'd like. You can pause, you can try it the opposite way of what I'm doing and see if you still get the same answer. I'm just going to go left to right, so minus 4x plus 9x, and there we go. 9 minus 4 gives us 5, great. And when these two multiply, they should multiply to the outers, which was negative 36, great. So all of this was developed through noticing what happens within a distribution. Alright, let's move on to the next step, which is grouping. So we take two at a time and notice what greatest common factors we can take out. From the first two terms, we could take out a 4x, which results in a 3x minus a 1. Remember, if it's exactly the same, you still need a 1 to keep the place. The next one, we can take out a 3, which leaves us with 3x minus 1. And lo and behold, the brackets are the same, which they should be. And you'll find they always will be. So we take out the 3x minus 1 as a common factor, and we're left with 4x plus 3 out of these two terms once they are factored. All your little negatives and positives are contained within brackets, which implies to us that it is in factored form. Let's take a look at the next example here. You'll notice the leading coefficient here is negative 16. So, as a rule of thumb, you always want to take out any common factors that you possibly can, and you always want your leading term to be positive, because it makes these guys nice and positive, and it also works better later when you're trying to simplify rational expressions and so on. So it's cleaner to take out the negative, so let's do that first. If we take out a negative 1, that will result with 16y squared plus 10y plus 1. So this guy is going to just hang out all the way to the end. It's not going to move, so make sure you include it. Lots of people forget it. Make sure you don't forget the common factor that you take out. So now, within that, we're going to work on factoring 16y squared plus 10y plus 1. Because the leading coefficient is something other than 1, we want to split the middle term into two numbers such that the product is going to be 16 times 1, which is 16, and the sum is going to be 10. So what two numbers multiply to 16 and add to 10? You have 1 times 16, 2 times 8. Oh, I think that's it. You could keep going, but 2 times 8 is it. There's always one option within here that will work. So we can write this as 16y squared plus 2y plus 8y plus 1. Now we can group it. So really it's only two steps. Split the middle term and group it. Take out a common factor out of the first two, which is a 2y, giving us 8y plus 1. And out of the next two, you can just take out a 1, which leaves you with 8y plus 1. And that way the bracket is the same. It can come out as a common factor. And you're left with 2y plus 1. And we have factored. So now you can't forget this negative that was hanging out, because whatever common factor you took out to begin with needs to stay in the answer. If you multiplied all this out with keeping a bracket and then putting a negative back in, you would basically backtrack back to the expanded form. Let's take a look at a couple more examples. Sometimes your trinomial is not given in order, in which case we want to put it in order. So let's put it in order 25a squared, so decreasing exponential form, minus 40a plus 16. Now we can say that, hey, our leading coefficient is not 1, so we can't go directly into the brackets like in the previous lesson. We need to split the middle term and use decomposition. The product that we're looking for these two terms is going to be whatever multiplies to 25 times 16, which is a really big number, 400. But it seems like a nice number. And sums to negative 40. So we need to think of two numbers that multiply to 400 and adds up to negative 40. If you're not sure right off the bat, you can go systematically and write out all the ways of multiplying to 400 until you see that because the product is positive, we're looking for a sum of 40. So two numbers that add up to 40. You could keep writing these out, but you would eventually lead up to 20 times 20. 20 times 20 is 400, and 20 plus 20 is 40. However, since our sum is negative, that means both of them need to be negative to give us that. And check. Negative 20 minus 20 is negative 40. Negative 20 times negative 20 is positive 400. Great. So we keep our 25a squared. We split our negative 40a into negative 20a minus 20a, and our positive 16 stays. We've split the middle term. Step 1. Step 2 is to do grouping. So what is the greatest common factor between 25a squared and 20a? Well, we've got 5a that comes out, leaving us with 5a minus 4. Now here, because we want positive as our first term in the bracket to be the same bracket, we want to take out the negative to change both signs. And we also have a common factor of 4, which leaves us with 5a minus 4. Great, that's exactly what we wanted. We wanted the same term so that it became a common factor for the two terms that we have, the two clusters, and we're left with 5a minus 4. And hey, look at that, we're done. Because this is the same thing, this is actually could be written as 5a minus 4 squared. You can choose that option, pick either one. If you go on to the next lesson on special factoring, you'll notice that this indeed could be simplified and done with a bit of a shortcut if you know your patterns well. However, it also signifies to you that if you don't notice a pattern, you can always fall back to this process and still get the answer. Last example here, we got 3x squared plus 6 plus x. Again, it's not in order. Please order it with decreasing exponential form. Okay. Now we can see that the leading coefficient is not 1, so we need to split the middle term, find product that is the first times the last, giving you 3 times 6, giving you 18, and a sum of 1. So we're looking for two numbers that multiply to a positive 18, meaning they're going to add up to 1. So let's look at all our possibilities. 1 times 18, 2 times 9, 3 times 6, 4 times no, 5 times no, 6 times 3. Those are all the possibilities, and we want them to add to 1. Do any of these add to 1? Yikes. So in this case, nothing works for splitting the middle term. Therefore, there is absolutely no way to factor this over the integers, and so your answer can be that this is a prime. So there is no way of factoring this expression over the integers. So please note that that is possible, and it's very important that you are able to write out all the possibilities so that you can justify that you haven't just missed one, you don't actually have one.